right, I'm just going to tee up our next session. We've got the AI inference spectrum. So what you're going to learn about in this next session is whether you're building agents, you're working with LLMs. You have all sorts of different choices as to whether you're going to use GPUs, you're just going to use APIs. And so Jeff is going to walk us through a lot of that and also how to not get locked in to one specific thing as things are changing. Let's give it up for Jeff.
Thank you, Matt. Oh. So good morning, everyone. Well, I need to be very transparent. Being the last session before lunchtime makes me both excited and a little bit worried. But I promise I will finish before your stomach complains. So just before we dive in, I need your help. So first questions. Whose company is currently doing AI model training? Please raise your hands. Around 20 people. The second question. Whose company is running AI inference workload? Please raise your hands. Oh, I see more, like 40 people. It is not a coincidence, and it's also not just random things. It is the futures. Let me give you some data points. Last year, Q4, NVIDIA just disclosed that AI inference workload at their data center just grew from 0% to 40% in just a few years. You may think about why there's a shift. Actually, it's quite natural because training actually is a one-time investment. You train, you finish, and then you just terminate the resource. But inference is different. Inference is your ongoing revenue source. Every API call, every ChatGPT conversation, every recommendation by the AI service you are using, it is inference. And with a lot of people, they start to use AI. We call this AI democratization. The traffic just explodes. But there's a technical question behind of it. What is that? Is your AI infra ready for large-scale inference? Is ready? Yeah, some people nod their head, some people just, I don't know. I get it, because it's very hard to answer. But actually, you know what? It is a good problem to have. That means that your AI service is in high demand. Let's take a look on the flip side, from the supply side. Right now, there are around 2,000 services, AI services on the market, in app, in the SaaS formats, plugin format for the browser. And when you think about, all right, which tool should I use? Should I use this one? Does that fit me the most? What about the GDPR? What about the vendor locking? You freeze. This is what we call decision paralysis. And when you freeze, you lose the time to market. From weeks to months, just so hard to make these decisions. If that sounds familiar to you, actually, you are not alone, because this is what we are going to tackling in the upcoming 30 minutes. My name is Jeff. I'm a solution architect at DigitalOcean, based in Munich, Germany. Before I joined DigitalOcean, I was a DevOps engineer with focus on scalability and Kubernetes. And today, I'm going to tell you what you will walk away with by the end of these sessions. The first one, a scaling path from prototype to production without vendor locking. The second, the resource optimization strategies, how you can best utilize the underlying GPU hardware resource to the maximum, and also your existing data with your existing system. The third one, a code template on GitHub that you can just use to deploy a GPU cluster with Kubernetes in 15 minutes. I also got a bonus for you, because we have a customer flew 10 hours from New York City to London. They want to tell you why they choose DigitalOcean and how they deliver their promise to their users by using our services. So let's get started. Over the past couple of months, around 2 years, our solution architecture team spoke to 100 of customers, AI startup founders, and business adapt AI. We compile into a framework. It is consists by 4 stages and 4 needs. You may think about, hey, Jeff, 4 stages. How can I remember which stage fit me the most? Let me help you by applying how do you like to eat. Sometimes you may go to the family restaurant, get everything. It is all in one place. Sometimes you just want some fast food, the In-N-Out burger, Shake Shack. Sometimes you want some customization. That's tailored for you. Sometimes you want to go to the fine dining. It is a journey from simple to sophisticated. Same thing applies to AI. So stage 1, using DigitalOcean Gradient AI platform. This is the all-in-one platform. You can quickly prototyping a RAG application, then deploy it. Think about family restaurant. You get a good protein, dessert, soup, cola, in one place, very quick. Stage 2, serverless inference. This is where you can use model as a service and connect with your existing system. Think about the fast food. For example, like I just mentioned, the animal style burger from In-N-Out, amazing. You don't want a whole pack, you don't want a cola, you just want the burger. And stage 3, GPU droplet, you can use it to train, fine-tune the model and inference from there. Think about private chef. So for example, personally, I don't like chicken wings. I don't even like chicken legs, but I love nuggets. I really like nuggets. I can eat 20 pieces just in 5 minutes. So if I need to host a party that feature with no chicken legs, no chicken wings, but nuggets, I need a private chef. In this case, GPU droplet is your best friend. Last stage, you need the microservices. So when you get a lot of traffic, you will use the microservices. Think about the fine dining, the Michelin star. It's always fully booked. The appetizer, the main course, the dessert, they all got their own special, but coordinate perfectly. Similar to the Kubernetes plus GPU. Over there, you got a lot of traffic, but you still need to serve with quality, even under very heavy workload. It is Kubernetes services with GPU. So I want to get started each stage with a more clear use case, with a personal story. 5 years ago, I was still a DevOps. Around December timeframe, I need to serve the on-call rotation. And in the midnight, my pager just went off. So I get up. This is the time that I need to prove, hey, this is what I got. Try to match the patterns from the runbook and apply the resolution. Actually, it's quite excited when you were young. Just like this guy. Fixing production is not like the hero movie, like from the Marvel, but it's like this guy. Messy, a lot of things you need to do at the same time. But that is not the most exhausted part. The most exhausted part is to do the post-mortem. Post-mortem, you can think about like a post-incident analysis. DevOps engineers, platform engineers, we want to learn. Why did it happen? How did it happen, and what can we improve from there? In general, we want to let the incident pay the dividends in the future. But wrapping up a report for post-mortem normally took around 4 hours for me. I need to sort it out, the timeline. I also need to think about, all right, what did I did during the midnight? You know what? You need to think very clearly after a long night. This is the most frustrated part. 5 years ago, AI is not that accessible. But what if we can use Gradient AI platform to make my life much more easier? For example, I can upload like a 1 gigabyte server logs in CSV format into a gradient AI platform and start to configure like which model I want to use and put a prompt like, hey, acting like a incident archaeologist to sort it out the timeline, find the patterns. And then with just a few clicks, I deploy. In my case, 1 gigabyte data from 0 to deploy took around 20 minutes. The result is very rewarding because when it's being deployed, you can start to interact with the chatbot. It will start to help you to sort it out the timeline very quickly and give you some patterns or tell you, all right, this direction probably it's normal. You should focus on this part, divide and conquer. At this stage, it's very crucial because right now the incident just being resolved. So it's very low risk, but it is very high reward. And I want to emphasize the last point. It is a turning point that you start to trust AI. From AI skeptical to AI believer. I want to associate back to the previous session, our British gentleman, Jack Pierce sessions, that you start to trust the AI that they will not replace you. They're here to enable you with a better life. That is stage one. So right now we are using stage one, the post-mortem bot, to resolve the incidents, to find out the root cause, to do the post-mortem report. The natural reaction would be, what if we can prevent it from happening? Can we integrate with our existing system to capture any signal to prevent the business downtime? This is where serverless inference chimes in. Check this one. Serverless inference, we're acting like a model as a service, like a socket. You can use different open source models, Queen, Llama, DeepSeek, anything that you support from DigitalOcean Gradient AI platform. And if you want to create like an SRE AI assistant with 3 different bots, observability monitoring chatbot, log agents, capacity planning agent, you can just connect with your existing database, monitoring, and also DevOps stacks. And the final stage, integrate with a notification app like Slack, Telegram, OpsGenie. So it will notify you when there's something unusual just happened. This is where serverless inference will chime in and help you to integrate with your existing systems. What about stage 3? Stage 3 is where like generic model fails. Oh, let me put it this way. It is not, I shouldn't say it failed. Generic model, they are great. For example, if you think about generic model, it's like a Swiss knife. It can open your Christmas gift, open the envelope, nice and easy. But what if you need to curve a door? You can still use Swiss knife, but you need a lot of effort. In here, you need a fine-tuned model, which means a more expert model. So stage 3, GPU droplet will become your best friend. On the training side, you can use H100 droplet for training, for fine-tuning, and apply the LoRa to your model. You can also define your MLOps pipeline, how you want to train the models. And the best part is that our Amsterdam data center also supports GDPR compliance at this moment. This is from the training side. Let's take a look from the inference. 2 months ago, we did a benchmarking internally against another leading AI services to get AI. Under the same system setup, our throughput is 143% better, which means that we generate more tokens in a second. For the latency, we are faster, 33%. And for the cost, on the average, we are 40% cheaper. In my opinion, using GPU droplets to do training and also inference is not just a double win. It's a game changer. Let me tell you why. Because right now, you put your own expertise, you put your own domain knowledge, or in general, you put your own company DNA into the model and fine-tune into your specialty, fine-tune into your own model. That is an asset that separates yourself from other competitors who use the same tech stack. This is a decisive moment to make the game different. So just want to iterate that the H100 GPU droplet and also the bare metal, they are available in New York, Toronto, and also Amsterdam at this moment. So from stage 3 to the stage 4, you need microservice architectures. And standard microservice architecture, they are not wrong. They are also very good. But maybe you can think about how we can refactor into LLM native architecture. I want to get started with an example. So this is the examples that I learned from our customer. They are very shy, so I can only tell you the use case. For example, let's say we have an AI companion app, like AI boyfriend, AI girlfriend. And this type of app, they offer emotional value to people who is single, people who is lonely, or people who just want people to talk to. Imagine that at the very beginning, when their user is just 1K, all right, not a lot of people, and you ask your AI sweetheart, how are you doing today? She or he responds, I'm good, in just 200 milliseconds. All right, good. But right now it's get viral from 1K to 100K, and the cost also rise. And the experience get very, very worse. So when you ask again, hey, how are you doing? And he just started to respond like, I am good. If you're in a relationship, trust me, you will understand how does that feel with your partner. And you know what? Maybe next time, it will not just like, how are you doing? They will say, what are you doing? So I'm not kidding. Actually, I want to say I'm just kidding. So what I want to emphasize is that experience for this type of AI companion app really matters. If we take a little more deeper look, why it happened? Because we still serve the LLM workload with like a traditional or standard RESTful API way. On the left-hand side, you can see each of the square represent like the payload size. They are in a similar magnitude. But for an AI workload scenario, it's varied wildly. For example, some simple ask like, hey, summarize this article, translate this one into German, easy. The medium level, all right, I want to do some code review. I want to do some code generating. The more advanced one, okay. Can you plan a trip that from Munich to London with a baby infant together with a car seat? Plan a trip for me. It is very complicated task. As a result, it's very hard to control your workload because there are so many different contexts. How can we resolve it? How can we resolve it? Introducing the LLMD with DigitalOcean's Kubernetes services. LLMD is an open source framework that's supported by Red Hat and other infra providers that's designed dedicated for large-scale inference for large language model. They design for disaggregate serving, like prefill, decode, separation, to ensure you can maximize the utilization of the underlying hardware resource. So no idle of the hardware resource. The second one is designed for Kubernetes. Kubernetes native, okay. And the last one, smart routing experience. A very smart load balancing will allocate the workload to the appropriate resource to process your request. And right now, I'm very happy to announce that just a couple of days ago, DigitalOcean's setting, let me click. DigitalOcean setting has been accepted by LLMD GitHub repo, which means that you can find our guideline and our documentation at LLMD GitHub repo. And you know what? It's just a starting point because we do have very close collaboration partnership with AMD. And we would love to test and find out the best ratio threshold, how you can use AMD to deliver the best value. Just a quick survey. How many of you would be interested to know this ratio to use a different GPU silicon that deliver the best performance and the cost? All right, I see a lot. So roughly, we can put this one on our webinar pipeline. Okay, so right now you see the code, but if you would love to have some guidance, the tutorial is also ready because this is what DigitalOcean is so famous in the community. I would love to conclude my part with this last slide. Just a recap about what we just go through today. I get started with my personal post-mortem journey. So we use the great DigitalOcean Gradient AI platform to help me out, sort it out the timeline, and also find the root cause. And from reactive to proactive, we can use serverless inference to integrate with the existing system so you can capture the signal in a timely manner. When you want to moving from generic model to your fine-tuned model, the GPU droplet is a good friend at stage 3. And when the traffic is going to be very large, using DOKS with GPU and also LMD can help you to survive and become success in the future. So that is the AI maturity model presented by solution architecture team. Don't just take my word because I'm going to invite our New York-based customer to the stage. So please give a warm welcome to Prashanti and also Carlo from Traverso.
Thank you. Can you guys hear me all right? Yeah. All right, so my name is Carlo. I'm one of the founding engineers at Traversal. We're based in New York City. And actually to get started on what Traversal actually is, I think the best thing is to actually contextualize it in the wider software engineering system. So where do we fit in the engineering toolkit? Software engineers have 3 main responsibilities. First one is to design software. The second one is to implement those designs in code. The third one is to deploy that code, watch it break, and start debugging. We iterate through those 3, and that's about it. That's about all we do. And the past 2 years have actually been amazing because we've seen how AI tooling has shifted the way we work in almost every aspect. So for software design, we have tools like ChatGPT. That's where we start iterating, we start brainstorming, and then we have great tools for coding like Cursor, Zed, Claude, which have also been amazing. But for debugging, we're still using the same tools that we were using 10 years ago, the same dashboards. Not much has changed. So then that's where Traversal comes in. We've actually seen it firsthand in this past couple of months, seeing how engineers are starting to think differently about their production systems once you actually integrate LLMs and AI agents. Ooh. All right, so I think it'd be very useful for us to be on the same page about what the observability and monitoring problem is in complex software systems. So let's all get on the same page. So let's imagine we're all AI engineers and our VP of engineering came up to us and was like, hey, we want you to code up an AI SRE. It shouldn't be that hard. Our engineers are having a ton of incidents. Let's make it work. So what do we have? So on one side, we have an observability system. We have a terabyte of logs, a terabyte of metrics, and a terabyte of traces. That's 3 terabytes of observability data. And for you guys that have seen large systems, this is actually not a lot. Then on the other side, we have LLMs. LLMs have a 200,000 token context window, which is roughly about 1 megabyte. So essentially what we're trying to do is shove in 3 terabytes of data into a 1 megabyte context window. So for all of you guys that are good at either multiplication or division, if you had to guess how many LLM calls we have to make to contextualize all our telemetry data, what would you say?
1 million.
It's actually not bad. It's pretty good. It's pretty good. Thank you for not overshooting too. All right, so it's 3 million LLM calls. And the interesting part here is that this is data that is generated daily by your system, which means you can't just do it once and be done with it. You have to constantly be running these LLM calls. So it's 3 million LLM calls. It's not going to work. So we can forget about it, move on, try something else. So I think it'd be good also to pause and say, well, how are humans solving this problem today? We have a ton of data on one side. How do we actually make use of it and grok it in a way? So humans today, how we're tackling this problem is through dashboards. We create dashboards, more dashboards, and then we create alerts. And those dashboards serve as a starting point so that we as humans can start navigating this ocean of data. So the problem, though, becomes that monitoring is hard. It's built one incident at a time. With every new incident, you create a new dashboard, you create a new alert, and it just takes years to build a comprehensive suite of dashboards that can explain your system. So all right, so now that we've seen how humans are solving the problem and where we are still the AI engineers, we're like, all right, so instead of pointing the LLMs to the observability systems, let's point it instead to the dashboards. And let's let the LLMs parse the dashboards and figure out what's going on. And that actually works a little bit better than pointing it at the observability data, but it still doesn't work. One, because dashboards don't generalize. They don't exhaustively explain the complexity of the system. They only work for predefined enshrined metrics. That's the first issue. They don't generalize. The second issue is that humans are still doing the hard work. Humans are still going through the system, creating the dashboards, and that is a known hard problem. So I think now that we have a built-in intuition for the problem that Traversal is solving, it'll be good to start looking at how Traversal actually works under the hood and look at the architecture. So Traversal, let's actually imagine a user query. A user asks a question and says, hey, the billing page is not loading or users are reporting the billing page is not loading. What do we do? At that point, the question is forwarded to the RCA agent. RCA agent means root cause analysis. I guess a term engineers will be familiar with. At that point, the agent receives the question. It'll make a hypothesis about where in the area of the system the answer probably is. It'll send the question and the hypothesis down to the causal agent. The causal agent at this point has no data, so it will forward the question to the data agent to actually make the retrieval calls, which will then call the query for logs, metrics, traces, all the observability data. The data agent gets the data back, and at this point, the data agent will use machine learning models and LLMs to filter, parse, transform, and enrich the data, and it will send back the process data to the causal agent. The causal agent then uses another suite of machine learning and LLM models to start creating relationships across the different data points. If the causal agent is able to arrive at a good explanation for the observed system behavior, it will return the response to the RCA agent. Usually that doesn't happen in the first try, so the causal agent will call the data agent again to get more data, and then get more data, and it'll iterate until finally it returns a response to the RCA agent. The thing is, the RCA agent at this point can say, hey, actually, though your explanation does explain an observed system behavior, there's actually a red herring. This is not the issue. Keep looking, keep searching. So it'll call back to the causal agent, and this iteration will continue many times. At this point, you might be thinking, well, the sound's actually pretty slow. That can take a while. And that's actually true. It is kind of slow. And the way we've solved this problem is by massively parallelizing the agents. So the RCA agent doesn't just make one hypothesis, it'll make many hypotheses and make many parallel calls to many causal agents. The causal agent will then make many parallel calls to many data agents. So you can imagine this fan out of requests, of layered requests across different agents. So that's how we've tackled the observability problem. And the way I like to think about it, it's like a search tree problem. You have a massive search tree that an agent is traversing, but most of the search tree is noise. So how does the agent efficiently navigate this search tree and prunes branches off the tree? And that's how we're using LLM models and other machine learning models. Prashanti will get into exactly how this works and how we're leveraging DigitalOcean infrastructure for our AI needs. Ooh. There you go.
Can everyone hear me okay? Thank you, Carlo. So we just saw how Traversal's architecture looks like, but the real question is, how do we actually make this all work in the face of enterprise scale outages? So just last year, a faulty security upgrade from CrowdStrike triggered crashes across millions of Microsoft systems, disrupting hospitals, grounding flights, just halting operations worldwide. That kind of cascading failure is exactly what Traversal is designed to anticipate, explain, and help resolve. So the challenge here is that all of this raw telemetry data, the logs, metrics, configs, traces, it's just overwhelming. By themselves, they don't mean anything, it's just noise. So what truly matters is how these billions of events sort of connect with one another. The way Traversal extracts these causal relationships is through 4 ways, basically, as you can see. There is temporal, which basically captures any time series spikes and lags, stuff like that. There's semantic, which interprets any sort of text data, logs, error messages, anything that has to do with text-based data. There's spatial, which maps dependencies across services and infrastructures, stuff like that. And then finally, there's statistical, which uncovers any sort of correlations that aren't super obvious to the eye. So together, these sort of cover the full spectrum and map all of these billions of events and cut through these signals and actually explain why an incident happened. So in order to be able to do this, we have 4 AI needs primarily. We need to be able to train ML models, fine-tune agent architectures. There's evaluations for benchmarking purposes, and then also production, where we saw that speed, trust, and reliability are super critical. So that is exactly where the DigitalOcean Gradient AI platform sort of helps us deliver at scale. So for training and fine-tuning purposes, we rely on GPU droplets. They provide us with on-demand compute without the overhead of actually managing hardware clusters. And then for production, serverless LLM inference and GPU droplets are basically our backbone. They provide us with elastic scaling and super low latency so that when an incident actually happens and our usage spikes 10x, Traversal can still respond within a few seconds. And combine that with DOKS, or DigitalOcean Kubernetes, as we saw earlier, where we actually deploy our software. We have resilience and operational simplicity all in one place. So the architecture diagram, which we basically saw earlier that Carlo was taking us over, ends up looking something like this. So Gradient AI becomes the reason we can act both as a research lab and a production system all at the same time. And the impact is real. Just in the past month alone, we've made over 1 million serverless inference calls on Gradient, and we've seen 99.96% availability just straight out of the box. And with model fallbacks and retries, we've effectively gotten to 100% availability. And here's the fun part. This isn't just a one-way partnership where Traversal runs on DigitalOcean. Traversal is actually also live within DigitalOcean's own internal infrastructure, helping their engineers triage incidents in real time. So in a recent case study, we actually found that Traversal has helped over 45 plus DigitalOcean engineers across 54 incidents. And of these, 82% of these incidents were considered in scope, which means that our AI was able to reason over 82% of all of these incidents. And then of these debuggable incidents, in 84% of those cases, our AI was able to find the exact, the smoking gun, which is the exact log, the metric, or the pull request that actually triggered the whole incident, basically. So yeah, in conclusion, this isn't just a vendor platform relationship. It's a collaboration where a global cloud provider and a nimble startup like us come together to build the future of reliability. And we're only just getting started. So if you found any of this interesting or you think Traversal could help your organization, we'll be around. We're happy to chat, answer any questions that you may have. But yeah, I'll hand it over to Jeff for now, and thank you so much for being here.
Great. Wow, you know what? As a solution architect, every time you have a cost testimonial, you always learn something. In my opinion, when you try to solve the root cause, you think about the hypothesis first, and then you validate that, and then you resolve it. You know what? On the way to London, I got an idea for their marketing team, how to promote Traversal in UK. So how many of you is based in London or in UK? Please raise your hands. Great. So when I say, see it, say it, sold it. Fantastic. So similar to Traversal, with a minor tweak. You think it, and you test it, and then sort it. Wow. Let's give another big applause to Prashanti and Carlo. All right, I know your stomach is going to complain, so take a picture for this slide because it contains 3 small gifts. First one, a $200 credits that you can get started with DigitalOcean. The second one is a GitHub code template that you can just deploy DigitalOcean's Kubernetes services with GPU and also install LLMD in 15 minutes. You can use it as a POC. If you got some new ideas or advanced idea you want to talk to the solution architecture team, scan the 3rd QR code. We will have time for you. So thank you so much for your time, and let's have some talk during the lunch break. Thank you.